This is a gecko skull, and this is what it actually looks like. This is a crocodile skull, and this is what it actually looks like. Now guess whose skull this is? It's actually a rhinoceros. Yeah, if you compare it with the gecko and crocodile from earlier, you can clearly see we mammals have lots of facial flesh. Meanwhile, the dragon clan next door, which includes lizards, turtles, crocodiles, and birds, have their faces are mostly bone. That's why we can easily eat a sheep's head as a whole meal, but a duck head is only enough for a snack with drinks. So, the dragon is a symbol of imperial authority. But why is that? So why do reptiles look like walking skulls? Actually, if we flip back a few more pages in the family trees of dragons and beasts, we'll find over 300 million years ago, our earliest ancestors basically had no facial muscles. At the time, we were all just lizard starter packs, all wandering around with poker faces. But all that changed with a massive eruption of the Siberian supervolcano 250 million years ago. Everything turned to dust. On the wasteland left after the end Permian mass extinction, the reptile lineage, once crawling in the dirt, suddenly rose to dominance, especially around 233 million years ago in the late Triassic, when they evolved into the peak of reptilian evolution. The dinosaurs, from then on, the dragons ruled supreme, with no rivals in sight. By contrast, the beast clan, once sitting atop the throne, found their dominance crumbled. After struggling repeatedly, they ultimately failed to hold on to their dominant position. In the end, only one branch called the Cynodonts, these humble beast descendants, managed to scrape by. That's right. This included our ancestors. Back then, they were only the size of rats. Their claws and teeth were small and weak, and that was it. So how did they survive right under the noses of all those mighty dinosaurs? Simple when their eyes were shut. Our ancestors hid deep in their burrows during the day, only sneaking out at night to forage for food. This nocturnal lifestyle lasted nearly 200 million years. During those long, dark ages, our ancestors had to rely increasingly on their sense of smell and hearing, and evolution would drastically remodel our bodies to accommodate this. To further enhance our sense of smell, we developed an additional piece of cartilage that protruded forward in front of the nasal openings in our skulls. This formed the first nose. This extra nasal passage could preheat the air we breathe in and recover heat from the air we breathe out, thus preserving body temperature through long, cold nights. More importantly, this process inevitably creates turbulence in the nasal cavity, extending the contact time between air and olfactory receptors, making our sense of smell much sharper. But this trick also brought us an unexpected bonus: the chewing function that evolved around the same time and gave us more flexible, multi-bundled masseter muscles. Our ancestors stumbled upon the discovery that by fine-tuning the snout with the masseter muscles, they could get the facial skin to pull the cartilaginous nose side to side. Once the nostrils could move side to side, they gained more precisely directed smell without having to turn their heads. Over time, our ancestors' nostrils swayed with increasing range to pull the skin on both sides of the nostrils more effectively. Several bundles within the masseter gradually migrated forward and eventually broke away from their original position altogether, and instead attached directly to the cartilage of the nostrils, forming a series of specialized muscles for controlling the nostrils, such as the nasal muscles and nostril dilator muscles. From then on, our mammalian ancestors had a nose that could wiggle significantly from side to side. Anyone who's had a dog should be familiar with this. And the nasal muscles, nostril dilators, and other muscles that control this flexible nose became some of the first muscle groups on our faces. But that wasn't all. To improve their hearing, their ear canals extended outward into a cartilaginous megaphone. That's right, the outer ear, commonly called the ear. Then, the same evolutionary program was repurposed for the ears, redirecting some of the original neck muscles to the face, allowing us to hear in all directions from then on. And let's not forget, we're mammals. Especially back around the late Jurassic period, mammals picked up a legendary evolution buff, which is nipples, allowing infants to latch on and suckle. No milk lost, no evaporation, no wasted milk, chunky babies. So obviously, whether it's sealing your lips or puffing out your cheeks, both require muscle involvement. So mammals evolved the orbicularis oris muscle, and our faces became fleshier as a result. So you'll see, when it comes to gaining weight, it's always either never or countless times. And this whole set of muscles not only gave us full faces, more importantly, all this facial hardware inadvertently unlocked a whole new tech tree we never imagined. Look at how we focus, tense up, get scared, and so on. All of these require our head's sensory organs to respond accordingly. For instance, when facing danger, to protect our delicate ears. Animals instinctively pull back their scalp and flatten their ears, or pull back the corners of their mouth to bare all their teeth. This both intimidates and allows them to bite at any moment. At the same time, they often lower their brow. This protects the eyes while blocking out distracting light, allowing the eyes to better focus on the threat. All of this makes our facial expressions change with our emotions. Yes, the first hints of facial expressions began to emerge on our faces. Of course, in the beginning, these muscles that had just migrated to the face were still pretty crude in their function. Just like modern marsupials, such as opossums, a single muscle would move a large area of the face. The range of expressions they could show was probably limited to just a few, and likely didn't serve much purpose for communication. But right at this critical moment, about 66 million years ago, an uninvited asteroid suddenly disrupted the original timeline. When the dust settled and our ancestors looked back, they discovered that the dinosaurs who once ruled the world had vanished for good. Their time had passed. With no dinosaurs on Earth, the mice became king. So our ancestors, as representatives of eutherian mammals, began mimicking the great dinosaurs and emerged into the sunlit lands. Their body size quickly expanded as a result, but soon after, they felt like a cornered prey. Surrounded by threats, with our soft, floppy big nose and big ears, we're basically wearing our weaknesses on our face. Even predators smaller than us dare to get right up in our face and go all out. We can't keep living like this. It's embarrassing. The problem is, the ear and nose positions are already locked in. Even if God himself showed up as the client now, there's no changing the design specs. So all we can do is slap patches on top of what we've got. Like, we can already tweak the direction our features face a bit, right? So I'll just crank it up and make the ears and nose move even more. Maybe it could help dodge an enemy's attack. So the muscles in our faces went through yet another round of expansion. For example, eutherian mammals evolved a small procerus muscle between the eyebrows. When contracted, it creates a furrowed brow. Below the nose, the depressor septinancy muscle was added. It can pull down the nose and upper lip. Anyway, each side of our ancestors' facial muscles grew to nearly 30 in one go. So almost every tiny patch of face got its own control cable. This made it possible to produce extremely complex and varied facial expressions. Our modern sense of facial expressions now had an anatomical foundation. Of course, being able to make expressions doesn't mean you have to use them. In fact, the vast majority of mammals today also rely more on scent, vocalizations, and physical contact, body movements, and even tails and rear ends to communicate with each other. Even animals like wolves that can pull off some basic expressions are basically weirdos by mammal standards. This is partly because our mammalian ancestors lived a nocturnal life for way too long. Their vision was poor. They really couldn't make out subtle things like facial expressions. On the other hand, most mammals only fight face-to-face, rarely interact face-to-face. But one group of mammals is clearly an exception. That would be the primates, especially those of us with a rather underdeveloped sense of smell, the Hoplor hinds. After all, our ancestors evolved specifically to spot ripe fruit at a glance, as well as snakes lurking in the foliage. They developed the finest vision among all mammals, particularly skilled at observing details. Plus, primates are generally social creatures. Usually, with the tree canopy in the way, it's hard for everyone to get a good look at each other. Any real communication pretty much comes down to staring eyeball to eyeball. So we've got to wear our whole story on our faces. For this, we even evolved specialized neurons just for reading faces. And just like that, evolution entered the face card era, and facial expressions, which were already closely tied to emotions, became especially exaggerated among primates, turning into emotional signals deliberately displayed for others to see. For instance, among old world monkeys, the bare teeth display became a ritualized gesture, signaling subordination from lower-ranking individuals to higher-ranking ones. This can be understood as me taking a defensive posture toward you. That would mean I'm weaker than you and scared inside, so it represents submission. Among capuchin monkeys, individuals lower their brows while approaching when meeting new friends, meaning, I'm willing to interact with you, but I'm still unsure if you pose a threat, so I'm using the brow position for watching threats on you. What's even more amazing is that facial expressions as a language are hardwired directly into our DNA. The upside is, no learning required, it comes standard from the factory, and usually doesn't need translation when facing different groups. But a side effect is that all expressions are made subconsciously. Even when there are no companions around and no social needs, individuals will still naturally make these movements as conditioned reflexes. In short, facial expressions have been with primates ever since, but if we look more closely, we'll find humans and monkeys don't seem to share the same joys and sorrows. At least human smiling generally isn't used to express fear or submission. So where did humans get this system of emotions? No wonder we humans are the giants among primates, as the once small predators no longer dared to get in our face. We no longer needed to swivel our ears to detect danger or stare into the bushes to spot predators hiding in the shadows. But the ancestral expression code has left an indelible mark on our faces. When we're scared, we still instinctively pull our scalp back, but since the muscles around our outer ears have atrophied, we can no longer pull off airplane ears. Only the remaining muscles raise our eyebrows and widen our eyes, and since there's no longer a need to stare down danger, the furrowing of brows that originally helped lock one's gaze simply disconnected from vision altogether. From then on, whether the danger was actually seen or not, humans would furrow their brows whenever under stress. But the most revolutionary change is that our jaw shrinkage caused by increased brain size meant we permanently lost our ancestral fangs and large teeth, making bare teeth no longer intimidating. So showing teeth with a grin, the connotation of submission that evolved from our primate ancestors, gradually overtook the original meaning of this expression and further evolved to represent all meanings of friendliness and even happiness. Thus, we finally have this awkward yet polite smile. Of course, if we're being technical, the threatening meaning of baring teeth hasn't completely disappeared either. Just think about it. When we give that devious, wicked grin, don't we pull our mouths back further and show more teeth? Before human language truly emerged, facial expressions became virtually the only medium for complex communication in human societies, able to express and read more diverse, more nuanced expressions, undoubtedly had a better chance of securing higher status within the tribe, and, incidentally, leaving behind more offspring. So perhaps, starting around 5 million years ago, facial expressions became the primary driver of human facial evolution. Look, most of the differences between us and other great apes in the Hominidae family, in terms of facial features, stem from expressions. Our faces are chubbier because our facial expressions are more diverse. We naturally need more and larger muscles. We have thick, rosy lips so that subtle movements of the mouth stand out more. We also have larger eye whites to highlight our gaze. Even our eyebrows may have been retained partly because they can signal frowning, but most importantly, in our brains, the specialized neurons responsible for parsing faces began to rapidly expand, and this unexpectedly unlocked a whole new skill tree. That's when we began to distinguish and encode different sounds produced by movements of the tongue and mouth. But that's a story for another time.